Hi, and welcome to DCO. In this video, I'll be showing how to create this subdivided floor pattern using a few steps. We'll be starting with the overall geometry, offsetting a band, then on the inside, creating a pattern using circles, then from there, creating the details for the grout line, and then creating what you see here. So I'll be going over all of the steps, and so let's jump right in. All right, so to get started, first thing we'll do is bring in a point. So we'll go here to construct point and then plug that into a point component. This way we can move this location at any moment by creating a point here in Rhino and then setting a point. And now here we can start creating a rectangle. So this will also be a base, the base curve that everything will be created with. So let's give this a pretty good size. We'll go 20 by 20. And now we can use this as the base geometry for creating our design. So I'll plug this into a curve component. This way we can also change the curve into a different polyline if we want to. So now let's move on and start creating the design that's going to go on the inside of this. And so the next thing we'll do is take this line and we'll offset it. So we'll go here to offset curve, and then we'll offset this base curve. Now it does offset it to the outside, so if that's okay with you, then you can kind of leave it. But I am going to offset it to the inside. So I will create a negative and then offset it to the inside. So I'll go 1.500. This way it actually gives me a slider that's from 0 to 10, and it gives me 2 decimal points. So this is going to be the outer band. And we are just starting with the base geometry, so creating the outer band. And then on the inside, we can also subdivide it in different ways. But for that, we are going to use a particular design. On the outside, we'll just be creating a band that has subdivisions on the outside. So for that, we'll need to create a surface here and then a surface on the inside. So let's go here to boundary surfaces and plug in both the outside and inside one, holding down shift to add another one, and then we'll flatten the input. This way we have that outer band and it creates a surface between those two lines. Next thing we'll do is we'll take the inside line, we'll copy this down here and plug in the polyline into boundary surfaces, and we don't have to flatten this one, but that creates that surface. So basically we created this parametric overall shape, and we can also plug in a different polyline and it will do that also. What's useful for this is, let's say you have a floor plan design or something and you want to create a nice entry with a kind of like a cool display interior floor. That's kind of what we're going for here. So having the outside band, what we're going to do is take this inside line and we're going to divide it using divide curve. The other thing is we actually need to explode it, because if we plug that in here, you'll see that it's not even. Like they don't always land in the corner, and we do want them to land in the corner. So we need to explode this curve using the explode curve component, or the explode, let's see, yep, the explode component. And now we have the segments here that we can plug into the curve. As you can see, we have it subdivided, and it does subdivide it evenly. So there will be some differences in the way that this gets subdivided. So we'll just keep that in mind, that the subdivisions are going to look a bit different. And that's going to be in the way that we'll subdivide this. So we'll take these points, and if you visualize that this curve got divided by 10 points, and so here in the count we can change that. And so if you visualize that we have subdivided this line and also this line into 6 points, well, what happens is that we'll have redundant one here. So we'll have 2 points, 2 vertices on each corner, and we don't want that. So the way to fix that is going to be here when we have the point output. We're going to have to plug that into a call duplicates, and that will get rid of the duplicate points, which will be at the end. And you'll see that now we have 24 points rather than 28. So with that, we can actually use the Voronoi command to subdivide those points like this. And therefore, using those cells, we can then split what we want here. So we could either take these cells and split the BREP, or we can extract the geometry. So there's 2 ways to do this, and let me show you those 2 different ways. When you have these cells, we can technically just go here to this surface and go to split, and we'll go here to split BREP multiple. And so we'll take this surface and we'll plug in those cells as the cutters. Now you'll see here that we have 24 trimmed values. So we can disable preview here. And you'll see that now we have those subdivisions showing up here. And it's just due to us dividing it evenly by a number. So that is one way of doing it. And the other way is going to be where these cells intersect this surface, we could extract those lines. So we can go here to intersect, BREP, curve, and now we can intersect this BREP with the cells that are technically lines or curves. So now we can extract those lines, and then from those lines, we can then split it. So it would basically do the same thing, but that's 2 different ways that we can extract that geometry here. I'll actually delete this one and then disable the preview on all of this. So now I don't really need that. All I care about is that I have this output, and this is going to be kind of that outer frame. The other thing is that technically we don't have this split down the corner, and sometimes you do want that. Let's say if you want to create a tile, you don't, this would be a difficult tile to cut. One way to fix that will be to take the outside and inside curve, and rather than creating a boundary surface between the two, we'll actually create a loft between the outside line, do that again, the outside line, so the top one, and then the inside one holding down shift, which is this one. Now I'll flatten the input, and it will actually, so let's disable the preview on all this stuff just to kind of show you. That will actually create this diagonal. And now this is actually what we could use as the BREP to be split. So now it actually creates, go here. Now it actually creates it with that subdivision. And I think that looks better in terms of construction. So with that, we have the base geometry for the outer border, which is a detail that for the most part is kind of critical when you want to create like a nice entryway or like a nice detailed floor. So now with that, we'll go to the inside surface. Let's see if it's this one. Yep. So now with this, we'll use this as the base geometry to create the next pattern. And so the next pattern will also be using the Voronoi Subdivision, which is this one. But we'll be creating an intricate pattern in here using circles, and you'll see how intricate you can get using just simple circles and intersections using points. So with this base geometry, one of the things that before I move forward too much, I just want to move it around a little bit just to show you some of the things that it can create. And obviously, if we create it as a perfect square, it's going to create the perfect subdivision. So maybe that's how we'll keep it for now. But in reality, let's say the room might be a different size one way rather than the other. And maybe that's something that we can fix. But for now, we'll move forward and create the pattern in here. So with this one, we'll bring in the center point. So we'll go to area. The next thing we'll do is, now that we have this center point, we're going to create a circle. We'll go to circle and go plug in the centroid into the plane. And the radius, we'll use a number, so 150. That's a little bit too big, so maybe we can kind of lower the limit here, say 100. And so this is going to work as, we're going to focus just on creating the pattern using the circle and this point. So now we'll create a division. Divide curve. And we'll plug in this circle into the divide curve. And now we'll create a subdivision amount. So we'll go here to a slider, and we'll go 2 less than 9. I don't want to go too crazy. And this way we have created kind of this subdivision of points around that circle. Now we can create a line segment. So the line component, and we'll bring in from this centroid to the outer points. Next, we'll take those lines and we'll divide them again. So I can take this, slide it here, tap Alt, and plug in that curve into the division. Now this one, I do want it to be less. We'll go here to something like 3. And now the next thing is going to be to create some circles that will be based from those points. So we'll take these circles, and I'll actually create a new one here. So I'll create a new slider and a new circle component. Plug it into those points, plug those points into the circle, and now we'll go here to something like 5.50. And of course, these can always change because, for the most part, it's going to depend on the area of what you are creating. And now this is getting into some like sacred geometrical stuff like Metatron's cube and stuff like this, but all it is we're subdividing a circle using points, connecting it, and then subdividing it again and using circles again. And so here we'll change the upper limit to 20. Now let's move this around a little bit. Next, we'll take these circles and plug them into a component that will give us all of the points that where the curves intersect. So here we'll go to multiple curves, and that, when we plug that in and flatten the input, it gives us all the points that intersect. And so those points are then going to be extracted and placed on a Voronoi. What I am seeing is that there are at some points, so let's disable the preview on everything except for the points so we can see the pattern that it's basically going to create. But there are some places in which it does kind of mess up a little bit. So we'll keep an eye on that, and we'll take this and plug that into the Voronoi component. And Voronoi, all it does is it takes a set of points and it creates the most efficient subdivision according to the set of points. And so that's kind of what it's used for also in nature. So we'll plug in the points in here, and we'll see that when I flatten the input, we're getting now some weird pattern that's starting to look very geometrical. So let's disable the preview on this. Now let's take a look at the patterns. So here we can start by basically increasing the overall size of the base circle. Let's see if we have that. So we can visualize kind of the overall area. Now here we can start playing with the circles. And let's change the slider here. And I think the larger we make the original circle, the issues with the pattern start happening more on the outside. So here we're playing with the amount of subdivisions. So these are 8. So we can go down to a lower number, something like maybe 6. And then here, this is going to get into more intricate pattern. So the more subdivisions in this way we have, the more intricate it's going to be. So we'll go here to 3. We'll keep it fairly simple. And we can always pull the slider and get it going kind of crazy. So having those subdivisions, 3, 6. We're flattening this one on the outside, and then let's see if we could do all duplicates to remove duplicates. So let's see if we have here 768, and then here we have 400. So what's happening is sometimes we have redundant geometry or redundant points, and that's actually probably messing up some of our output here. So now also that we don't have redundant points, we're seeing that the component is no longer like orange. So now this is working for us. So that's also something to keep an eye out on. And so here, let's go through and play around with some of this stuff. So we're just pulling on the sliders, and I'm trying to get a pattern here that I can then use to subdivide the floor. And sometimes for me, it's hard to visualize when I see all the points. So let's move this. So I'm just going to keep going here till I get a cool pattern. So I'm going to need to subdivide it maybe by 6, 4. Then let's move this around last time. I think here we'll get a cool pattern. There. Okay. So now here, we're going to do the same thing that we did to this one, which was subdivide or use the multiple brep. We're going to unplug these, so before that messes us up. And sometimes that's could be an issue because when you plug it in, then sometimes it does a component, runs a command that's really long and sometimes gets your computer stuck. And that's happened to me in the middle of tutorials where I'll be almost done and then one last thing kind of throws everything off. Now let's go here to our brep, and you'll see it will take a little bit of time for it to calculate. And when it does, it will give us that result. Now, I learned this trick, which is going to be the way to see what it's going to look like before we run the command. This way you can actually do the slider smooth without it bogging down, because now that we plug this in, as soon as I move this slider, you'll see that it's 42.48. Now let's go to 43. And you'll see that it's going to then have to recalculate everything once again. And that's not what you want to do. So one way to fix that if it brings me back Grasshopper. Yep, it was here hidden. Okay. So as you can see now, this is the pattern, and it took a little bit longer. So one of the things that would be important to do in this case is going to be to use this in between. So we'll use the intersect curve with brep, that wasn't it, brep and curve, and we'll use these cells as the curve, and then the brep is going to be the surface. I can technically double click in here to bring in a relay, and then use that relay to plug into the brep. So it's calculating again, and now when I plug it in here, we get this pattern. So one of the things to do is to unplug cutters. So holding down Control, I can unplug the cells. I can visualize what it's going to look like and move the sliders freely here. Because when you're just intersecting geometry, it's not as heavy as splitting an entire brep. So what I'm doing now is here, we're going to use a dam or a data dam. And this way, when the information goes through here and through into the cutters, now I can visualize what it looks like. And when I finally say, okay, that's the pattern I want to use, well, then I click here on that, and then we'll have to flatten the input here. And now it's going to, here's the thing. It has to go through the cells. So let's unflatten here and let's press play. Now we have our result, and now when we change the slider, this is going to change, and then it's going to ask us to refresh whenever we want to do it again, and we'll just have to preview it using this. That's hopefully that made sense, and that's a way to optimize your script so it doesn't bog you down, and you can actually visualize your data and what your output is going to be before you actually calculate it. Okay, move this up. Okay, so we basically subdivided that geometry, both the outer band and the inner patterns. So we'll go here to brep and then plug in those breps or those segments, and then we'll plug these also. So we'll just bring them out here and have them ready to view. And now here, we're going to apply some materials. We'll go here to custom preview. Okay, so now that I've plugged in a color swatch into this one, it just gives it a little bit of a different color so we can visualize it. And then here, we can also play around with some of this stuff. The next thing is they are technically here, everything is kind of super watertight in terms of it being all right up next to each other. So if I extrude this, it's actually going to extrude it, and you're not going to see the difference. So let's see if we can try a trick here. So I'll unplug the preview, and I'll take this and I'll bring in an area component. So every one of those has a different area. This has a small area, that has a bigger area, this has a bigger area, that has a smaller area. So visualizing it in those terms, we can plug those B-reps into here and get all the different areas. So one is 5, one is 12, 6, and so on. And they're all tied to that specific geometry. So what we can do is bring in an extrude component, and we're going to be extruding it up, of course, in the Z direction. Nope, I thought about something better. We're not going to even be extruding it. We're going to be moving. I mean, we could extrude it, of course. If we're moving something, we can also extrude it. But I'm thinking now when I look at it, I think the thing that I'm going to do might look better, but possibly not. So let's go this centroid. We're going to move that up by the area. And it's too extreme. So this is where we can divide the area, or we can remap the numbers. So there's two ways of doing it. Remapping the numbers, we can be really subtle. That might be better. So we'll take the area component and we'll remap the numbers. This way we can pick exactly the smallest one where it's going to be and the biggest one where it's going to be. Now let's go here to remap numbers. So when you remap numbers, we bring in 3 different components. This is also on my free resource tab on my website to download the remapping numbers, but I'll show you here. You bring in 3 components at the same time. You bring in remap numbers, you bring in bounds, and you bring in construct domain. So every time I remap numbers, this is what I bring in. And those are the 3 that I always bring in. So the reason why I tell you that is because sometimes people go like, oh, how do you know which one? It's like, no, I always bring in the same ones, and you have to kind of remember what they're for. This is going to remap the numbers, so we have to plug in the original values into the values. Source is going to be what's the biggest and smallest number. So when we plug in the area into bounds, which is this one, this will actually give us the smallest number is 0.06 and the biggest number is 33. So we'll plug in that into the source. Next, we're going to tell it how big do you want it to be, because right now it's not mapping them any different. We need to change the smallest number to be, let's say, we'll go here 1.50000. So we have a lot of decimal points, and we'll go to a small number and a big number. And as long as you have these 2 values here for the start end, then we can remap the numbers between 0.2 and 2. So now I can disable the preview on everything here, and I can say, okay, the smallest one, let's bring back the pattern. So the small ones get the small value, and the big ones get the big value. And just thinking, like, if this is going to be a floor material, then possibly this might not be the best idea in terms of it's going to be bumped up, but maybe that could be part of the tile design. So now that we have those points that vary depending on the area, and we have remapped them to be fairly low, otherwise it would be kind of crazy because they're kind of up, way up here. Now we can do extrude to point. So we have these points. These points are going to be what we extrude to, and then we're going to be using these B-reps So now as you can see, it extruded those out to the point, and it further creates this other truncation, I guess you would call it, where if you go to the midpoint and you extrude, you actually create more geometrical subdivisions. So that in itself further complicates or exaggerates the pattern. And so I feel like that's also kind of a cool, neat feature that we came out with here. And so let's bring in the geometry or the display or the custom preview. And let's take a look at what that looks like here. And let's move some of the sliders around, right? Because this is fully parametric. So we can always come back here and play around with those. The thing is, we want to display this to see what pattern it's going to be eventually. And so here, I'll disable the preview on this, and we can see this is what it's going to look like again, or now on the new one. If I change this around, it's based off of 5 now, and I find a cool pattern, let's say that one, then I'll click here on the plus sign. It's going to calculate, and now I can go back here and preview it again, and it will calculate it. Using that pattern. Ultimately, if this is just going to be, let's say, a floor tile design, we would actually take a different approach. So we'll call this an option. Maybe this could be like a feature wall or something that could be more of a display. And we'll unplug this, holding down Control. And here, now we'll be creating some grout lines. So offsetting this to the inside, possibly just by using a scale. And then we'll have a cool pattern that then we can use as a tile, and it will be way more obvious this way. We can also change subdivisions, because here we have it at 5 and before we had it at 6, and I feel like that actually looks really cool. So let's move this around again. There it is. Okay. I'll use this one. Now we can disable the preview on this and take a look at what that looks like at the end. Now we can use this pattern and we can scale it down. Okay. Let's take those, or this burette. I'll group this, move it to the side. Okay, and now here with this one, I'll bring in the area component. So once again, the midpoint. Now we'll be using scale. So I'll plug in the geometry, and we're going to be scaling it relative to each and one of those center points, and just enough that it leaves a gap between everything. So we'll go 0.999, disable the preview on everything else, and now let's move this down a little. So here's the thing, that creates uneven gaps. And so maybe that's not the best way to do it. The best way to do it, it's going to be to do this. So it's a little bit tedious, but I feel like it's going to give us the best thing here. And some of these things are a little bit tedious in terms of it takes a while for it to kind of be exactly what you want. So if I want this to have a perfect spacing in between, then I have to do certain things. Like I have to join this brep. This way, it's all one and we don't have overlapping lines here. We only have one segment. Now I can do the brep edges because I can extract the inside and outside lines. And so with that, I can do multi-pipe. So this is a bit of a trick here to do the interior lines because that's really what matters here. Caps will go here to round and we'll change the size of it. So I'll go 1.500. And if you guys have seen my videos before, I typically multiply two numbers to create the proportions for the multi-pipe here. So I'll go here to multiplication and I'll multiply these two numbers. And that's to keep the proportions between the two. And so this goes into the node size and offset. And this then goes into strut size. Now we can decrease kind of this value, and this one takes care of the connection. Now that we have this entire sub D pipe, and it's all one because we only have one line segment, and it creates it really clean here, we're going to go to intersect brep with brep. So this pipe, the sub D pipe is going to go into this brep. Now it's not a brep, it's a sub D, so that might give us an issue, but here at the end, I'll go to boundary surfaces just for the outside surface and intersect it with that. So now this becomes the line work. And it's evenly everywhere, and you can actually play around. And this is where we also would do a data dam to do this, because it's going to take a while, right? Like if I change this a little bit, like it's gonna take a while for these connections to update, and you can see that also on my cursor. So this is where we can create a data dam in terms of it here. Before it goes into this one, we can take a look at what it's going to look like. And then if that's what we want, then we press the play button. I'll disable the preview on that. Next, what we need to do is take this and let's see here. Go to boundary surfaces. So it creates it for that one, and then region difference between the overall offset, this one, with this region, and then this, if it works with this one. So it's not letting us do it. So let's go here to boundary surfaces, see if create a boundary surface that will work, or if then. Okay, so if that's the case, then I do have to go in here into this one and go to deconstruct or explode. And then join them again as individual segments, all of these. And then do boundary surfaces. Let's see if that works. It creates a boundary surfaces for all of these separate segments. It does. Okay. So that is a different way of doing it. Now, as you can see, after this, like it's a very heavy, intense calculation to come down to creating kind of like the grout, the tile. We don't need that. And now we don't need to preview any of. So we have this. The last thing I'm saying that can fix that issue is going to be all of these. Going to be this one. Doing region difference between all of these and this one. So graphed, because it's going to do all of them individually, and this one. So we'll use this one for the top, and then these for the bottom. So we'll have to use two different colors. So we have this one. And I'll extrude that a little bit. So we'll go here in the Z direction. And use this as that input. And then we'll do the same thing, extrude it up now using this, but we'll be extruding and using a different color. So as long as we extrude this one out a little bit more, so we'll say this would be 1.5, and then we'll do minus 0.5. For this one. And if we want the difference between the two to not be so much, well, then we go 0.1. And if that's the grout thickness, well, then we'll make the extrusion for the outer band the same as for So hopefully you found that useful. For the most part, the cool thing is creating kind of these custom patterns using circles and then extracting it. And from there, we can, add more details. We added the grout line, we added the subdivisions and the outer band, we extruded it up. And so here at the end, I'll be doing more than anything cleanup here of the script and a few renders to kind of present it. So thank you very much for being here and for watching, and I hope to see you next time. If you'd like to get a hold of the script that I created for this video, check out my website, capetti-david.com. There you can become a ScriptBulb member where you can access all of the video scripts that I've created for my YouTube. You can access also the script store where I have optimized scripts. And lastly, if you want to learn Grasshopper and you've never tried it, or you want to share that with someone, I have a 6-module course that will help anyone get started. I post videos like this that will teach people how to get started using Grasshopper, so make sure to subscribe for future content. I appreciate you being here, and I hope to see you next time.